CRANESInspect is a project funded under the FP7. Its aim is to monitor the structural health of cranes in order to prevent its fatal failure. An example of this failure has unfortunately been shown in Brazil this year. All the consortium members are European companies, and the crane studied in this project is located at the port of Rotterdam. The fundamental objectives are to detect, evaluate and monitor the damage, as well as increase the confidence in the process. To reach this goal, NDT techniques have been used, such as AE and guided waves, along with parameters correlation and trend evaluation. First of all, the critical zones of the crane were identified. A modelling analysis of guided waves based on finite element was performed in the reinforcing plates of the crane, as they were identified as the most prone to damage. This analysis included modelling of guided waves propagation and acoustic emissions AE in steel joining plates. A system prototype has been specifically developed within the CRANESInspect project. It is embedded in a bespoke enclosure. It also includes specific components for monitoring such as AE and LRU equipment. PZT sensors have been designed with dual capability of transmission and reception for this project. Analysis including modelling of the behaviour of the sensors was developed. Laboratory trials were performed during the last months of the project. 3 sensors were installed to transmit and receive on a metal sample. The transmitting channels were located on the side of the system, whereas the reception can be found in the front. For the reception, preamplifiers are used to amplify the signal received. The use of them makes necessary the use of decoupling circuits. In the experiments, a crack is induced and its size is increased. The software starts the acquisition when an acoustic emission signal is received. In this case, the signal is simulated by the standard procedure of a pencil lead brake. Once the signal is received, the source of the signal is graphically shown. After that, a pulse is transmitted through the transmission sensors to focus on the source, and the signal is received by the sensors. The software shows the crack size depending on the error function, which is calculated from the signals received. Several tests were made with different crack sizes: 1, 2, 4, 6 and 9 mm lengths. The CRANESInspect software includes artificial neural networks for defect classification. The neural network has been trained with real data and data obtained during the experimental testing of the system in the laboratory. Wi-Fi communication is also included in the system. The module utilises a band of frequencies based on a high-speed protocol with an amplification signal from 12 to 20 dB. During experimental tests, the speed meter showed a 5 to 6 megabyte per second streaming sample without data errors. Apart from the laboratory trials, as part of the project, a set of experiments were performed on the crane located at the port of Rotterdam. The sensors were installed on the critical areas identified at the beginning of the project and mounted using a specific holder to produce over 60 psi of pressure and ensure their proper operation. As previously completed on the theoretical side, the software was integrated with the whole system to start collecting data and monitor the crane health. The CRANESInspect counts with a public project website we encourage to visit for further information.